Okay guys, so today we're learning about completing the square, but before we can learn how to do this, we're going to review the binomial square from several chapters before. So you may remember that with something like this, when you have a number plus a number and the whole thing is squared, that there's a shortcut to squaring it, right? We can't just apply the square to the x and to the y. This answer is not x squared plus y squared, because squaring something means you multiply the whole thing times itself. So essentially this is going to end up being FOIL, right? But we do have a shortcut instead of doing FOIL on this one. And the shortcut is any number, if you have a number plus a number and the whole thing is squared, it's going to be equal to the first term squared plus twice of this term times that term. So twice of 2 times x times y plus the second term squared. This is the shortcut, okay? So what we're going to do today is we're going to, in order to solve this problem, we're going to make this side into a binomial square. We're going to find the third term. So you see how it says x squared plus 10x. We're going to find the third term that would make us be able to just solve it easily, okay? So the way that there was this guy named, I don't know, his name is hard to pronounce, but he was an Arab mathematician in the 9th century, and he had to solve this problem right here. And the way that he solved it was by saying, okay, I want to turn this into something that I could find the perfect square root of, okay? So what he did, he ignored the 39, and he said, well, if this was x squared plus 10x, what would I need to add to it to make this a perfect binomial square?
Plus 0?
Maybe. Let's find out. So let's say here is your x squared, and then from here and here, he split this value in half, okay? So he put 5x's here and 5x's here, and the question is, because remember, this is a number squared plus twice of the number times a number plus another number squared, right? The question is, what is the rest of the square? We're completing the square. And we want to say, okay, how do I get these numbers? Well, x times x is x squared, right? X times what is 5x? X times what number is 5x? 5. X times 5 is 5x. Yeah. And then the same thing over here. X times x is x squared. X times what is 5x? 5. So you can see that we have x plus 5 on the sides. Well, if we're multiplying x plus 5 times x plus 5, what is this number? 5 times 5 is 25. The unknown, the rest of this square needs to be a positive 25. Okay.
Is there any way to find that without doing the boxes?
Yes, we will talk about that without the boxes in a little bit.
To write the boxes down?
Yes, I do. Let's put the box in your note. Just this one was blank, and we found that it was 25. Okay. Now, we still have to have this be equivalent to the original equation. So we're going to use the addition property of mathematics to not only add 25 to this side, we also have to add it to the other side. We need to keep our equation balanced. So if I wrote plus 25 here, I need to write it over here as well. Now it's still equivalent to the original equation. Okay, and then I'm going to simplify, and I'm going to solve. Okay, this is where it gets a little easier. Do you guys have this square written down? Can I erase that? Mm-hmm. Okay. Okay, so 29 plus 35 is what number?
64.
Okay, 64. All right. Now, remember, we just made this into a perfect binomial square. We turned it into the number x plus 5 on the sides, right? It was x plus 5 times x plus 5. Okay. And now, How did we solve these equations that had the whole side was squared? What did we do to solve them?
Distribute the square.
We didn't distribute because that would put us right back up here. Yeah.
You did,
This is from last.
oh, you did x squared and then.
No, this is from before spring break. What were we doing to solve this equation?
Putting
To solve for x.
So it would be x plus 5 and x plus 5?
If we did x plus 5 times x plus 5 and we did FOIL, it would get us right back here. We want to solve for x. We want to get x by itself. So we want to get rid of squaring this side. So the opposite of squaring is taking the square root.
Yeah.
So we're going to take the square root of both sides.
Oh.
But remember, when we take the square roots, the answer could either be a positive or a negative. So there's going to be two possible equations. Square root of 64 is 8. All right? And this becomes x plus 5. So x plus 5 will either equal positive 8 or it will equal negative 8. You will get two answers for x. We'll do this one to be the positive 8, and then we'll redo it to say the negative 8. And solve both for x. We'll subtract 5 from both sides. This x equals 3, and this x equals negative 13. Yeah?
Yeah.
Okay, so these are the two answers for x. Now we do want to check them into the original equation and make sure they are both true. Okay, so we'll say, what if x was 3? 3 times 3 is 9. 3 times 10 is 30. 30 plus 9 is 39. That one is a true answer. Okay, negative 13. What, someone type in negative 13 times negative 13. Or you can just do, we know the answer will be positive, so you can just do 13 times 13. What?
20. Or not 26.
What?
169.
169
26.
plus 10 times 13 is 130. Wait, but it's a negative, isn't it? 10 times negative 13 is negative 130. So what is 169 minus 130?
139. I mean 39.
39. So both of these are correct. There are two possible solutions for this equation. Okay?
That took a little philosophy.
It did. It did. All right. We're going to do another one where we complete the square. Let me just get that number real quick. Okay, so here is another one. Let's say we have x squared minus 6x minus 16 equals 0.
These go in our notes, correct?
Yes. Okay, so we've got this equation. Now, in order to complete the square, I want the third term to make the perfect square. And right now, this one is not gonna make the perfect square. So let's get rid of this number for now. Let's move it across so that we have space to find that perfect square. So let's add 16, or
Isn't the
you know what, maybe let's just confirm it. Let's find out first. Let's put our x squared here, and we're gonna split this value in half. What is half of negative 6x?
Oh, negative 2. Negative 3.
Negative 3, negative 3x, negative 3x. And you can just double check by saying, is negative 3x plus negative 3x, does that equal negative 6x? Yes, okay. Then this is the third number that we need. So let's go ahead and find that. What number times what number equals x squared? X times x equals x squared. Okay. X times what number equals negative 3x?
Actually,
Yeah, x times what number equals negative 3x?
negative
3.
three.
Okay, double check on this side. X times what number equals negative 3x?
X times negative 3.
Negative 3. Okay, perfect. Now we have this nice little phrase, x minus 3 times x minus 3. The last term needs to be negative 3 times negative 3, which is 9. So this needs to be a 9. Negative 16 won't work. So what we're going to do is we're going to move it across. We're going to add the 16 to both sides. Okay. I should have written this down farther. I'll try to fit it. All right. X squared minus 6x. And then what do we want that third term to be? Plus 9. Okay. But if I add 9 to this side of the equation, to keep it balanced, I have to also add it over here. Okay, and now I'll get, okay, keep in mind, right, that this phrase was x minus 3 times x minus 3, right? I'm going to erase this. Okay, 16 plus 9 is 25. This can factor so perfectly into that phrase that we just found, x minus 3 squared. Okay, and now we can solve for x. So Cadence, what's the next step here to solve for x?
Square root.
Take the square root of both sides. If I do that, this answer has two possible answers. It could be a positive 5 or a negative 5. Okay, x minus 3 could either equal positive 5 or it could equal negative 5. Okay, and then we add the 3 to both sides to solve for x. X could equal 8 or x could equal negative 2.
When you're plugging it in, do you plug it into the original equation? Or
Yes, the original, not the one that we've edited. We'll plug it into the original equation. Yeah. Okay, so Ellis, let's check x equals 8. So what will this first term be?
64.
Okay, 64. What's 6 times 8?
48.
Okay, so you can use your calculator. 64 minus 48.
16.
Okay, minus 16 will equal 0. So this is correct. All right, Cadence, check negative 2. Be careful when we plug it in here. Negative 2 times negative 2.
Which would just be positive 4.
Positive 4. And what is a negative 6 times a negative 2?
Positive 12.
Okay, so positive 4 plus a positive 12 is
16.
positive 16, and a positive 16 minus 16 equals 0. So
Zero.
this is also correct answer. Okay. All right, we'll do one more with the box, and then we will talk about how to not have to use the box. Okay.
Ellis is running out of space.
Let's look up the other side.
I would say that you may choose whether you want this one in your notes. It's the same process as the other two. So your choice whether you follow along or write it down. So this equation is x squared plus 14x equals negative 39. Okay. So I can already see that that number is out of my way. I'm almost ready to have this be a perfect binomial square. I just need to find what that third term is. So I know that I'm going to rewrite this as x squared plus 14x something equals negative 39. And whatever I add to this side, I'm going to add to this side as well. Okay. So I'm going to set up my numbers. I'm taking my x squared. I'm splitting this in half. What is half of 14x?
7x.
Okay. All right, and then I need to find what this number is. Okay, so what times what is x squared?
X.
Okay, x times what number is 7x?
7.
And x times what number is 7x?
What?
What? Cadence, x times what number equals 7?
7.
Okay, and both of these are positive 7, so I can see that the number is x plus 7 times x plus 7. But in order for that to be true, this has to also be 7 times 7. So what's this number?
49.
49.
There we go.
Okay, so we're going to add that 49 here and also over here. Okay, and then now what is this factored? What is, if we factor this expression, what will it be equal to?
X plus 7 squared
Equals 10.
Yes. This expression factored is x plus 7 times x plus 7, which is x plus 7 squared. Okay, and that does equal 10. So now, what's the next step, Ellis?
square root this thing.
Okay, and what do I write right here? X plus 7 what?
Just would equal. Because x plus 7 square rooted.
There's no square root.
There's no square root
There's
of
no
10.
square root of 10. So you have one where it's a positive square root of 10, and another one where it's a negative square root of 10. And then we solve for x by subtracting the 7 across. Well, we don't have like terms, so you're just going to drop it in front. So your two answers are x equals negative 7 plus the square root of 10, and another one is negative 7 minus the square root of 10. These are your answers. You don't have to simplify any further. Okay? All right, now let's look at how we can find this number without drawing the box. Okay? And it has to do with our shortcut. The middle term is twice of the first term times the last term. Twice of the first term times the last term. Well, here's the first term is x. So this is twice of x times the third term. Twice of x times the third term. Well, what is that number? Twice of a number equals 14. Twice of 7. Now, so this number, this y, is worth 7. But in order to get the third term, how do you get from 7 to 49?
Multiply by 2. My 7's
By 7. You square it, right? So you cut the middle number in half, this coefficient, not the x, leave the x alone. Cut the 14 in half, and then square that answer. So 14 cut in half is 7. 7 times 7 is 49. That's the shortcut to get there. I wrote it down. No, don't have it with me. Let me just write that instruction. To complete the square, how can we say this? Divide x's coefficient. What's a coefficient?
The beginning is the number thing.
The number in front of the x.
I was saying that.
Divide x's coefficient by 2, and then what?
And then
Square it. Square it. So if you look back at your notes from earlier, look at the first problem. That first problem said x squared plus 10x equals 39. So which number do we use to cut in half and square it? Look at the top number on your notes. The one that said x squared plus 10x equals 39. Which of those numbers do we use to complete the square?
10.
10. So we would say, okay, what's half of 10? 5.
5.
And what is 5 squared?
25.
25. So to complete the square, we need the number 25. And we'd add 25 to both sides. Right? The next problem that we did, that's in your notes, is, where to go? X squared minus 6x minus 16 equals 0. X squared minus 6x minus 16 equals 0. And then we were like, okay, we need this number to complete this square. So what number do we cut in half?
6.
Negative 6. Watch out for the negative. So what is half of negative 6?
Negative 3.
-3. And what is negative 3 times negative 3?
9.
Positive 9. So that's why we added 9 to both sides, right? Cool. All right. So here is the rule. You can write that down for future, and we can use that shortcut to complete the square now. Okay, we're gonna practice some of these. So we erase this part, and I'm gonna let you practice completing the square. All right. Before we solve one, see where I can find this. Before we solve one, tell me what term would create this trinomial square. Okay. So if I have the term x squared plus 8x, what term would need to be added to this for this expression to have a perfect trinomial square? Okay, you can tell me on your boards. Yeah.
Wait, what?
In order for this expression to be a trinomial square, what is the third term you would need? Okay, you do cut it in half, but there's one more step. You divide by 2, and then you 4 times 4. You cut in half, you get 4, and then 4 times 4 is 16. Yeah. So this term that we need is a positive 16. Now, what is this answer factored? Tell me on your boards, what is this expression when you factor it then? What's it turn into?
Wait, what?
Do you remember? It has to do with this one. If you have a perfect trinomial square, then you take the square root of the first term and put it here, and the square root of the last term and put it here. So the square root of the first term goes here, the square root of the last term goes here.
Oh, so yeah, for the top. That's the second time I got right.
Yes, and if it's plus or minus in the middle, depends on if this sign is positive or negative. If this was a negative, then you'd have a negative in the middle. If this is a positive, positive in the middle. So yes, so square root of x is x, square root of 16 is 4, it's x plus 4. Okay, and this works because we know it's a perfect square. We followed the rules to make sure the third term had that perfect square. Okay, let's try another. What term would you need? This is x squared minus 30x. What does the third term need to be in order for this expression to be a trinomial square?
Did I get an eraser?
Yeah. Tell me on your board when you find it.
I have to do the next one.
What's that?
That's fine.
You can borrow Ellis's, or I might have one.
Huh? No, I have my calculator.
Here, you can borrow mine.
Thank you.
Yeah.
I can't do that math in my head. Thank you. I'll make sure to give it back to you.
Okay. We need the third term that would make this into what's called a trinomial square.
Oh yeah.
Okay, I think so. Looks right. What'd you get, Ellis?
Is it 225?
Yeah. So same thing. We cut 30 in half, we get 15. 15 times 15 is 225. This number needs to be plus 225. Now that we've found that this is a perfect trinomial square, factor it. What will this equal? Yes. Almost. This, watch out for this sign. This sign determines whether it's plus or
I
minus.
thought it was the last one.
Is the last part right?
It doesn't say equal 0, so you wouldn't write equal 0, but if
I
it
thought
did.
you used the first and the last term and you take the square. So the square root of 225.
No, you did. I meant your sign was incorrect. So the square root of x is x, the square root of 225 is 15, but the sign in the middle is determined by this coefficient. So this will be a negative, and it will be, this will be squared because we split it into two pieces. Okay, let's try another one. Let's do, okay, this one's a little bit weirder. 25x squared plus 70x. Okay, what will the third term be?
You have to get it by itself first.
I don't think so. I think it's still, you see how the x doesn't really affect this last value? There's an x squared here and an x here, but it doesn't really affect this y. So you still follow the rule to divide this in half and then square it. Okay, so I guess so. I don't have my calculator with me, but 35 times 35, is that what you typed in? Okay. What'd you get, Cadence?
I don't know.
Is it pretty large?
I don't know.
What did you do to find your number?
I don't know.
Oh. Okay. What does this tell us to do? But not x squared's coefficient, just x. So we'll ignore that one. Divide this coefficient by 2
Yeah.
and then square it.
Yeah.
So what is 35 times 35?
Keep telling me error.
35 times 35. Was that 1225? Okay. Is that what you got, Cadence?
I was trying.
You can also do 35 squared if that's faster.
That would work.
Okay. Now factor this. Factor this. So in order for this to say a parentheses squared, we are taking the square root of the first term and the square root of the last term. Okay. So what's the square root of this? 5. And your x squared, the square root of x squared is x. You square both pieces of it. And then square root of this, we already know that's 35. And this is a plus sign, so we know it's adding those two together. Okay? All right, let's try to solve one. Okay, so the equation we're going to work through is x squared plus 4x equals 77. Okay, Ellis, what's the first thing we need to do here?
Find the third.
Find the third term that will make it the perfect square. Okay, so Cadence, what third term do we need for this expression to have a perfect square?
The third term would have to be like, well, you would find the x, but then 4 would be 2. So you would have to divide by 2, so then that would be 2. And then you would square, which means that would be 4.
Yes. Yeah. So you said you divide this by 2 to get 2, and then you square the 2, which becomes a 4 again. Okay. Now, if I add a 4 on this side of the equation, I need to also add 4 over here. So this becomes 77 plus 4 is that 81?
Yeah.
Okay. All right. And then we need to factor this side. We know that this creates a binomial square because we made sure that it would. So what are the two terms that go here? Okay, what's the first term?
It would be x.
X. Yep. And then what's the second term?
9. Well, 2.
Yeah.
I was thinking.
Yeah, ignore this right here. Square root of 4 is 2. And it was a positive, right? Okay. And we can verify this is true by our shortcut. We know we could do x times, if we multiply this by itself, it would get us back to this one, right? X times, the shortcut is the first number gets squared, x squared. The second term is twice of x times y, right? What is x times 2?
X times 2, so then 2
Is 2x. And what's twice of 2x? 4x. So that's correct. And then the last term is the y squared. 2 times 2 is 4. Okay, so we did that correctly. Equals 81. How do we solve for x?
You have to square.
Take the
I mean,
square root.
not square root, geez.
Yep. So we have one in which x plus 2 equals positive 9, and one in which x plus 2 equals negative 9. Okay. And then we solve for x. We get the two possible answers. Right? So x could either be, x could be such that it could be,
11 or 7.
okay,
Negative.
yeah, negative 11 or 7. This is our solution set for x. Okay, I'm gonna give one for you to work through on your own. It says x squared minus 12x plus 35 equals 0. X squared,
Can you leave the steps on?
from this one?
Or any of them.
Whoops. I'll leave
Fine.
I'll leave that part if that helps at all. X squared, where'd it go? X squared minus 12x plus 35 equals 0. Okay. Solve this problem by completing this square. Solve this on this board while y'all are working on it.
there's already the third equation, do you not have to find one?
You have to make sure that this term is a perfect square first.
Do that again?
You ask yourself, you
Oh, never mind, I'm done.
yeah, you find the perfect square and see if it matches. If it doesn't match, then subtract that number across so that you can put the correct one in its place.
Trying to see if I can do a long division.
Well, we don't want to factor this unless it's a perfect square. If it's not a perfect square, we want to move this over so that we can turn it into a perfect square.
I got stuck.
Let me see what happened here. Okay, so you subtracted 35 across. Remember that if you add 36 to this side, you have to also add it to the other side.
Where'd you get 36?
Okay, so we need to find this missing term, right? And so before we factor it, we have to find the number to complete the square. Okay, so instead of putting it all the way against the equal sign, let's leave us some room to add a third term. So we're going to rewrite this as x squared minus 12x plus, and then we have to say, okay, what's this third term? Well, how do we complete the square?
You have to do x squared.
Divide
Divide by 2.
divide x's coefficient by 2, and then
So
square that coefficient.
So it's negative 6.
Negative 6
Square.
and square
Which means it's 36.
36. So if we add 36 here, what else do we have to do?
Add it to that.
Add it over there. And now you can factor this because it has a perfect factor. The square root, hold on. Okay, so when you combined, that was a negative 35 plus 36. So right here, you accidentally added 35 plus 36, which is 71, but this is a negative 35. All right, let's look at this one. First, we want to check to see if this has a perfect square, right? We're going to check to see if that's true. You're on the right track.
Alright, I was just making sure for that.
Yeah, let's keep it right here. So, first of all, what is the third term that would make this a perfect square? Let's check. Divide the coefficient by 2 and then square it. So, divide negative 12 by 2, which is negative 6, and then negative 6 times negative 6 is positive 36. So, this is not the right number. We need to get rid of the 35 by subtracting it across. Okay, we can have x squared minus 12x equals negative 35. Now, I want this third term to be what number? 36. So I'm going to add 36, but if I add it to this side, I have to also add it to this side so that my equation stays balanced. Okay, now I can factor this because the square root of x squared is x and the square root of 36 is 6. And the sign will be negative, right? Because when we cut that 12 in half, it was a negative 6. Okay? This equals Negative 35 plus 36 is 1. And the square root of 1 is 1, right? 1 times 1 equals 1. So square root both sides. X minus 6 could equal positive 1, or x minus 6 could equal negative 1, because the square root of 1 is 1. So the answer is either positive or negative 1.
Are they going to be this difficult on our homework?
It'll be just like these. But I can post this video for so you guys have access to, so you can review them as you
Yeah,
work
I just
through
kept making like technical errors like in there.
Yeah.
I just got stuck.
Yeah. Well, this one ends up solving if we add 6 to both sides. Your answer is either 7 or 5. Those are the 2 answers for this one. Let's try one more. Let's do x squared minus 6x minus 9 equals 0. Minus 9? Let me make sure that's true. Okay, yep, equals 0. Alright, go ahead and give this a try. When you added that number 9 is the third term. It's not the one that goes in the parentheses. So you have the right idea though. So go back up. Instead of putting 9 in the parentheses, add 9 to both sides of your equation.
I did. Well, because
No, this number right here, this 9,
So if you have that and you double that.
then that number goes here.
Oh.
Add the 9. So you're right, you added that 9 across, but there's another 9 to be added to both sides of the equation. So start from there.
But was the 9 correct in the parentheses or no?
No, because then you take, to go into the parentheses, you take the square root of the first term and the square root of the last term.
Okay.
This seems wrong, but
Okay, I think this is correct. I'm gonna double check real quick. I'll solve this out really fast and then we'll be done for today. So I need to check if this could complete the square. So I'm gonna cut this number in half. Negative 6 divided by 2 is negative 3, but a negative 3 times a negative 3 needs to be a positive 9. So this negative 9 will not work. I need to move it across so I can put the right number there. So I'm going to add 9 to both sides. Now I get x squared minus 6x something equals 9. Okay, that number, negative 3 times negative 3, needed to be a positive 9. So I'll put my positive 9, I'll add 9 here, which means I need to add 9 here, okay? This 9 is only here because I moved that over. This 9 is here because I needed to complete the square, so I needed to add that 9 to both sides. So then I get the factor. 9 plus 9 is 18. Okay, factor this by finding the square root of x and the square root of 9. Whoop, it's not positive though. This is negative, so it needs to be minus 3. Okay, and then I square root both sides. 18 doesn't have a square root, so I'm going to simplify it. It could be 9 times 2, and 9 is 3 times 3, so I can pull out 3 square roots of 2. So I can have x minus 3 could equal a positive 3 square roots of 2, or x minus 3 could equal a negative 3 square roots of 2. So when I add that 3 across, I'm just going to drop it in front. These are a little weird, we're out of time, but it is x equals 3 plus 3 square roots of 2, and x equals 3 minus 3 square roots.
Finally got it.
I finally got that far too.
Awesome.
But my brain just died.